This seems like an unlikely place for fires. In the winter, the landscape is still, but the warmer months can bring conditions that, combined with fire, can release dangerous amounts of carbon into the atmosphere, and in more ways than one.
What happens in the Arctic does not stay in the Arctic anymore.
I see that you're wearing a hat with a logo on it. Can you describe what that is? You don't have to take your hat off.
Well, that's good.
Kevin, in the orange jacket, is a close NASA collaborator. He and his team are used to getting their hands dirty to collect crucial fire data.
I'm wearing a hat right now from the Above Field campaign, and what you see is a big A, and it stands for, the trees tilting over with thawing permafrost.
Trees aren't the only thing getting warped by thawing permafrost. Buildings and even roads begin to buckle when the ground beneath them literally begins to liquefy. NASA's Above campaign is currently in the Northwest Territories to understand large-scale changes to permafrost.
Permafrost is basically, picture in your mind, frozen dirt. Now, if you thaw the permafrost out, it changes from solid like rock or concrete to mud.
If you watched Season 1 of NASA Explorers, then you know that permafrost stores huge amounts of carbon. As a matter of fact, twice as much as what's currently in the atmosphere today. Now, thankfully, permafrost thaws really slowly, and therefore releases carbon really slowly. But here's where it gets complicated.
Fires in the high northern latitudes, permafrost regions, are getting larger, they're getting more frequent, getting more intense.
In the past, permafrost has had a reliable layer of insulation, mostly moss.
But if you have a fire, it burns off the vegetation. The insulation is essentially removed.
To summarize, changing climate means more fires, more thawing, more carbon in the atmosphere, and that accelerates warming. Permafrost is one of those important factors that affects life on Earth, yet it isn't really in the public eye, unless you live on it. But for Kevin, understanding this phenomenon is the best way to make the biggest difference.
See, way back in the 80s when I was in college, my mom got cancer and was dying. And I remember the last time I saw her, we were sitting down and she was in bed very sick. And she asked me what did I want to do. And until then, of course, I was a typical teenager in college. I had no clue. But then it crystallized in my mind that I wanted to save the planet, and that was the words that I used. And so I decided that my path for doing that was to go into spaceflight, save the planet by leaving it, I suppose. But then, circumstances changed, and then I started working on Earth observation. And it opened my eyes to what you can do with remote sensing and satellites, and what you could see and learn about the Earth from looking at it from space. And so I decided to go back to school, and I rethought of what I talked to my mom about, and I decided to go back to school, and I become a scientist.
The hours are long and the work is hard, but these explorers wouldn't have it any other way.
This is really, tough country. You're really rugged, but it's also a very beautiful country. I think I can speak for nearly every scientist that I've worked with. They do this because they want to help. They want to provide the information and tools to solve problems.
NASA is a big and capable organization, but Earth science is a subject far too big for one country, one agency to tackle all by itself.